Well, Josh, what are we out here to do today in Odd Jobs Hijinks?
Today, we're going to be doing something totally different than you've ever seen us do before. Reckless and I both are ham radio operators, KY4 BDP, KO4 OSS. We're helping out a fellow ham today. We're going to be putting up a tower for him, taking down his existing antenna that he has. It will go back on the tower, but we're also going to add another set of antennas. That's actually going to be a set of beams that we're going to have co-phased together. They're going to be stacked. And the objective here is to get him where he can reach out further. He's trying to get over 100 miles, 150, 175 miles out of this setup and be able to talk out of state, which is quite an achievement for VHF radio. And that's the goal here today. So we're going to be doing some digging, pouring some concrete. We're going to be manufacturing. We've got some aluminum we've got to cut and drill and tap out. And there's going to be a whole lot of different skills involved in this project today.
Well, this sounds like a lot of fun. And as Josh mentioned, this is part of what hams do, is help other hams. And he's going to have a really nice setup here.
Yeah, this is going to be a really jamming radio station when it's done here.
That's awesome. So folks, we're going to bring you along with this this tower build, and we're going to take down an old section. We're going to be digging a hole like Josh said. So stay tuned. In the next segment, we're going to begin this process.
I don't think it wants to come down, Brian. It's standing there all by itself.
Standing there by itself, isn't it? You'll probably ease it down, won't you?
You can stand on that.
Yeah, because
it's in the ground a little bit. It might flip up. Can you cut that tape, Brian?
Yeah.
And we should be able to just slide this right off. In order to get the coax out, we'll have to pull all this tape.
Yeah.
Off there. I did have to come back down here after I put this antenna up and take it back down again because it had gotten water in it.
Oh, did it?
And the water got in here.
Mm-hmm.
And when I got the coax off, there was ice between the bottom of the antenna.
Oh, really?
And in the PL259 there.
Right.
And because it's running vertical like this, I dried it all out, hooked it back up, and it still wouldn't work right.
Right.
This first 18 feet of coax had gotten water in it.
Oh.
So we had to replace this piece of coax. At the time, I actually had an analyzer that could read the coax.
Yep.
And right where it hit the ground, it was full of water.
Well, bummer.
Well, I've heard the stories of guys telling me that their water got in their coax and it got water into the shack through the coax. I've seen it happen. Okay. Just gonna set this off to the side, out of the way.
All right. So now we begin the process of digging our hole. And like I said, we're looking at probably 2.5 to 3 feet deep ultimately. We're just getting the gravel off the surface right now. Once we start hitting that clay.
All right.
And we're thinking 5 to 6 bags of concrete ultimately.
Yeah, this is really just counterweight down here at the bottom.
Right.
Since it's really going to be attached to the house.
And like a lot of places here in northern Tennessee, northern middle Tennessee and Kentucky, you're going to have pretty decent amount of clay. Not all areas have it, but it's not uncommon. But it's definitely not sandy. What are you thinking on a diameter for this?
16, 20 inches.
Somewhere in that ballpark?
Yeah, 2 feet at the max.
Okay.
It's really just counterweight.
How about a tape measure if you want to?
Well, being it's a triangular shaped tower, we're gonna have 2 legs parallel right here.
Right.
I want to make sure I'm wide enough here across this back.
Right. How many towers do you think you've put up in your?
How many towers have I put up?
Yeah.
It's been less than 100. And I've had 6 at my house.
Well, it could be 5 or that could be 93. You know, it's. I'm just kidding.
I'd say I'm somewhere in the neighborhood of above 20.
Yeah, yeah, absolutely.
Yeah.
Because like you got 3 or 4 at your place.
I currently have 4 at my place, but I've had 2 others there that I've taken down since.
Right. I mean, you're no Don Muncie, but you know.
No, I do not have quite the antenna farm that Don does. I'm working on it though.
Uh-huh. Shout out to AC4DM. He's got a pretty remarkable setup out at his place. All right, Josh, what do you think we got here now?
Got a pretty good hole here, Brian. We're about 24 inches deep. We're a solid 18 by 18 inches there.
Nice.
I think that's pretty good shape. Can't really go any further that way because we got the house footing we're contending with.
Right.
So we're just going to put a couple sections together and do a dry fit.
Right.
And see how we look plumb and everything. And then we'll put the whole tower together, stick it in the hole, fasten it to the house, and go from there.
Go from there.
Yeah.
All right. So now we're going to do a dry fit, and what Josh is doing right now is putting a couple of these sections together. This is a tower that was reclaimed, and a lot of times what you get when you get a tower that's been reclaimed is maybe some of the sections aren't as straight as they once were. We've got a bottom section here that we're just going to basically use as the base because it's pretty twisted on the bottom there, and you can see it a little bit, but in any event, that's what's going to go down in the hole is this end. And we're dry fitting right now just to make sure that it's the hole's in the proper place, that we don't have to move it. And it's pretty close. We're pretty confident, but you just never know. So we're just about to dry fit when we come back in the next segment. All right, I wanted to bring you back just a little bit sooner, but what Josh is doing here is you got 2 different sizes of bolts, don't we, Josh?
Yeah. We've got like a 5/16 and then a 1/4 inch, which is standard. I mean, that's how this tower was designed. Big bolt and a little bolt. I'm not sure what the engineer's exact thinking was on that, but I've seen it before. It's not like a...
Are those nylon nuts?
No, they are not nylon nuts, but I do have a lock washer.
Yeah. The towers get reclaimed all the time. Just my 5 years working with El Cara, I know we've probably reclaimed a dozen towers. And hams get in, hams pass, silent key, and the family doesn't want the tower anymore. And so we'll go take down the tower, and there'll be a new ham that comes along, and they need a tower. So it's a lot less expensive than buying them new.
And with the invent of digital TV, and cable and satellite and everything else, there's been less and less people actually using the old TV antennas.
That's right.
And back in the 70s, selling a tower for someone's aerial TV was the way to go, especially if they lived in a bowl or rural area away from a big city. They had to have.
And we still have a bunch of them here.
Still a bunch of them here. The antennas are broken and falling off. There's nothing to them. So if you're looking for a tower and you have a neighbor that's got an old TV antenna, it's sitting there and not using.
A lot of times they'll give it to you.
A lot of times they give them to you.
Yeah.
It's work to take them down and clean them up. And that's a really good way to get a hold of one.
And this has still got most of the zinc on it. I mean.
Yeah, this thing's in pretty good shape for I don't know how old it is, but wherever it was,
It's not rusted.
Sometimes what will happen to these is that the tubes will fill up full of water.
Right.
They don't put any gravel in the bottom for drainage.
Right.
and then right at the ground line, it'll freeze and it'll rupture.
You'll blow them right out.
Blow them right out, and then there's not a whole lot you can do with that piece.
You got to buy a new section.
Yeah, it'll ruin the whole section. You definitely don't want to climb on something that's had a freeze rupture.
Right.
All right, Brian, I'm gonna pick this up, stick it in the hole, just see how it looks on the roof line.
Sounds good.
I'm gonna have to trim a little bit up there.
You can see it's going to go past the roof line there, and that's what we want. We want to see how it's sitting in that hole and see what we might have to trim. What do you think there?
I mean, that's looking pretty plumb to me. But
let me get
I probably should get a level.
Let me get a level.
And I've got a pretty good eye. How good of it, we'll find out when Reckless comes back with the level.
Yeah, folks, anytime you're putting up a tower, you want to put a level on this thing multiple times. Right now, it's not critical, but we still want to.
And I've still got to trim the roof. This is just kind of a preliminary.
Pass the bolts.
That's not plumb that way. Let's check it this way here.
Go ahead.
So the bottom needs to come in a little bit more for it to be plumb where it is, and I'm still not in right there.
We need to kick those legs out a little bit, don't we?
Yeah, but that leg's bent. It's
Right.
already touching the dirt, so
Right.
I need to rotate this. Get that leg turning the other direction. And I can pull it
towards you.
that way.
Yeah. That looks better already. Oh yeah.
Oh yeah.
Most better. More better.
Can actually go back just a hair. Oh, that looks great. As far as this way goes,
That's pretty. Yeah.
the bottom could go back
That way a little.
a little.
Or we
And the
need
way
to-
that leg's bent, I think I need to rotate it one more time. By the time I make that notch
Yeah.
and push that top over,
Right. I think you'll
I
have
think that'll be perfect that way.
it pretty close that way.
You need to dig a little bit more right there, I think. Yeah, and I think
That's
we're in
pretty
good
close.
shape. Yeah, we'll have the rotor sitting right here,
Okay.
and we'll put the bearing.
Bearing plate.
The bearing plate will be sitting there. We'll probably have the rotor sitting down here, and we'll have a pipe that comes off the rotor up into the bottom of that pipe.
Right.
All right, so we still got some stuff to do. I'm gonna dig this hole out a little bit more on this side. I'm gonna make that notch up there. I'm gonna do that before we take this out, so I know exactly
Know where it
to
needs
make
to be.
And then we'll dig this out a little bit, take this back down. We'll put it the rest of the way together. We have to knock that bushing out of the top of that.
We do, because the pipe won't go through. Right.
And then we can load it all together, and we'll bring it in here. We'll stand it up. We'll bolt it to the house, and we'll be ready to pour some concrete in there.
Good deal. We're right there, dude.
You're on the bolts.
Still right there, dude.
Still right there.
Pretty close.
Both ways looks good, yeah.
This way is perfect, and this one is, just a smidge, but touching the line.
Okay. I mean, I could probably, we'll manipulate a little bit more, but yeah, I'm liking where
but you're
we're at
really
for
close.
attaching to the house and everything. It
Yeah.
all looks really,
Because that'll give us 2 legs against the house.
yeah.
That was your intent the whole time.
My intent the whole time was 2 legs attached to the house and just some counterweight at the bottom.
Right.
We are going to be 2 full sections above the roof line, a full 20 feet
Yeah.
above the roof line, but I think we're still not exceeding anything. I have a a taller tower with bigger setup at my own house.
Right.
Done the same way. And I don't even think my roof line is as high up the tower as this. I think I have maybe 3 full sections above the roof line
3
instead of just 2.
Right.
Yeah, I like it. I brought every possible tool I thought I might need today.
Right. He even brought his bandsaw. So I got a feeling he's going to cut off the tip there.
Got a really nice portaband here. That bushing's been in there for so long, it's going to be really difficult to try to drift it out. I had done this before, and I was thinking, how did I drift that out before? And I remember I didn't drift it out. I cut it off.
And the little bit he's going to take off isn't going to matter. So.
I'm going to remove probably less than 1/4 of an inch.
Less than 1/4?
Yeah. There we go.
No, there's no popping that out, is there?
No, it's been in there so long. They're basically welded together.
Of course, it's
And
freaking hot.
you know, this was probably, I'm going to say this was probably used as a TV aerial.
Right.
And the mast for the TV aerial was a smaller diameter, and that was needed to keep it from slopping around in there.
In there, Josh. Yeah, we got a nice clean cut now, and it's straight through, and that pipe will have no problem going through there. What we're using for our mast.
No,
Cool.
No problem at all. All right. Just keep pulling her on down there. We'll see. All the way. Keep going all the way in. I gotta feed this other one in too. Alright. That's about, see, the bottom of that's gonna be about right there, isn't it?
Roughly, yeah.
If we put our bearing plate right there, the bottom of this will be right there.
Right in there.
Right on that bearing plate. Now it's going to give about 8 feet of this one in here, so he'll have about 12 feet sticking up.
Yeah.
I wonder if we should cut a few feet off of it, off of this one, to get him down a little bit lower so he's not 12.
He's going to be sticking. Yeah, that's the full length, isn't it?
Yeah.
Because he probably wouldn't want more than, what, 10 feet sticking out the top?
I mean, I've got, on mine, I've got 14 and it bent.
It bent. And I think I've got 8 or 10 on mine.
Yeah.
8.
My other big tower that I've had my big X700 on, it's a 14-foot piece, and I had 12 of it out, and it didn't bend.
Right.
But it didn't have beams on it. It had just the.
And the mast wasn't this top rail. It was, what I have is actually like strong.
Heavy, it's 8 schedule 80 probably.
Yeah.
Yeah. No, I think we should cut 2 feet off of that.
Off of that one.
Yeah.
Well, there's your problem. It's 2 feet too long.
2 feet too long, buddy. You're on the last bolts, man. This is working good, bro. This is good. Get some more plumbing strap out, a couple more screws.
Man, enormous cost. Okay, sir. We're gonna lift it up, put it on the ladder.
Yeah, yeah. That's good.
Trying to get both legs.
So I'm gonna try to get it up over my head.
Yeah.
And you can just keep pushing the ladder up underneath it. That way, if I need to get a rest, we can. Then once we get to a certain point, we'll both just go for it.
Okay.
Okay?
So I'm pushing the ladder forward.
Yeah, so let's go up together.
Got it? Behind you?
Yeah.
Or you want me to be in front of you?
Probably in front of me.
Yeah.
I'm taller than the ladder. Another bite.
Pretty heavy, eh?
It's getting pretty heavy, and it's wanting to come back at us now. It's coming up out of the hole.
Yeah. Alrighty, well, in perfect hijinks style, we tried 2 methods that didn't work. Now we're gonna try a method that will.
So I'll pick my end up, and I'm just gonna kind of walk out around this way, Brian.
Yeah.
Just swing your end around, and we'll come back in again. Okay.
Do you need me to lift it all?
Huh?
I need to be helping you on this end, don't I?
Yeah. Get the ladder a little bit. Let me get my foot out.
Yep.
All right.
What you need?
I'm just gonna keep walking up.
Okay. There you go.
All right, come in. All right.
You good?
I'm fine.
That's what I'm talking about.
I'm pretty happy with that. Are you?
Bueno. House, what was it, about 35 for you, Josh?
To here?
Yeah.
Probably 45.
45. Maybe. But for our viewers in metropolitan areas, we live out in rural Kentucky and Tennessee, so 45 minutes for us is a nice country drive. That's more better there.
Very secure.
Yeah. Let's get you a better shot of what this looks like now in the hole. So again, we'll have to stack that piece. That'll come in a little bit. But now you can see how we've got it dug. Keep in mind, really, to keep this in the hole in the 6 bags of cement that we're going to use. The cement's mainly the anchor. But we've already got our mast pipe in there, and the rotor is going to be down here towards the bottom. We'll get the plates in and all that in the upcoming segment. So we'll be back here in a little bit. All right, Josh is bringing one of our last bags. We're gonna just dump it in, add water. That's 3.
Totally acceptable method of pouring concrete for this type of application.
Right.
Where you're just using it as a counterweight. If you read the directions on the back of this bag for setting a fence post, which is not horribly different than what we're doing.
Right.
It says pour it in there dry and hose it down.
That's exactly what it says. I use the exact same stuff when I install my mailbox post. And we use the same stuff when we install the entrance post at my place, didn't we?
We just did a solar array pad the other day.
Right.
Used the same stuff.
Same stuff. And we thought it would be about 5-6 bags. We've had a decent amount of rain. The ground was also wet. And so this stuff has a tendency to pull the moisture right out of the ground too, as it's setting up. We'll add water to this.
So the sand and the cement here has already been mixed. The sand, the cement, and the rock are all thoroughly mixed. Which when you're using a mixer, it's really what your objective is.
To get a good mix.
Is to get a good mix on all 3 of those materials. Once this is exposed to the moisture, like Brian just said, of the ground, it's going to get hard.
Josh, so what have we done here? We've got one of the masts in too?
Yeah, this is going to be our cross member. You know, to run a stacked set of beams. For they're horizontally oriented but vertically set.
Right.
So
it's like having 2 Yagis, basically.
Like having 2 Yagis, yeah, together. And what that does is it's taken, I don't know exactly what the gain is on these particular antennas. I'm sure it's somewhere in the 8 or 9 range each. And when you stack them together, you get 3 of the third one. So let's say that they're 8.
Uh-huh.
And he's going to add another one and get 3 more. He'll end up having a gain of 11.
Wow, okay.
Which is pretty substantial.
Yeah, absolutely. And when you're talking about doing those simplex contexts.
Yeah, and it's the same theory with what I have at my house.
Exactly.
I have the same brand of beams, but mine are 8 element. They're quite a bit bigger.
Right.
Their gain, I believe, is 14 individually, and I stacked them, so I'm at 17.
17.
That's still more than what you'd get out of a was it the 2 B213s or whatever they are, the big giant,
the big ones,
24-foot long thing that's like $500. I got $100 a piece in my beams. I'm getting more gain out of one of those. But yeah, this will be the horizontal cross plate brace. The beams will be attached to them. There'll be a central plate that holds it onto the mast up there. We're just going to go ahead and bolt these on and get them kind of set with the way they need to go.
Okay. So we wanted to get these set up here. I've got one in my hand as well. You can see peeking into the corner there. But Josh Josh is setting up the first one, and then we've got to find the co-phase harness for these, but I'm sure it's around. It's pretty cool though, the way it's going to shoot out like that. And then this mast is going to be attached to the mast sticking up out, and which is then attached to a rotor. So we'll be able to rotate these, or Jim will be able to rotate these based on who he's trying to make contacts with. Very cool. We'll be back once we get both these on. All right, so before we go have a break here, we wanted to show you what mocked up here. This isn't the final, but we wanted to show what's going to be close. And you can see these Yaggies here going across that mast, which we just cut top rail in half for that. And then this Yaggy. Josh runs a co-phase on his truck as well, except it's with whip antennas. But co-phase is not a new concept. It's been around a very long time. It's just that it isn't attempted as often as what you'll see typically. But
No, I actually like it because myself, you can get a lot more gain out of your setup than just what the antenna itself has to offer if you buy two of them and stack them. And if you shop around and do your research, you can find that you can buy two antennas sometimes cheaper than you can one.
With all those elements, yeah.
And those two antennas together are going to outperform that one. It is quite a bit of work, and there's some stuff you gotta do here. There's some math, some thinking you gotta do.
Not math. Are we talking trig? Are we talking calculus?
There's a little bit of math.
Okay.
Nothing too complicated, you know. Frequency divided by 468. Kind of stuff.
And now you already lost me.
If you got your ticket, you should be able to handle this.
Yes, indeed. Especially if you're a technician, that's one of the first things you learn.
Yeah, if you've got a ticket, you should have no problem handling what we got going on.
And the other thing too, as we're talking about tickets and licenses, you just need a technician license for what Jim is setting up here. You don't need a general, you don't need an advanced, because this is VHF, and so these frequencies are open to you. And this can get you, this could be a way to get into long distance communications without even going HF. So
yeah. This won't necessarily have to be used for contesting.
That's true.
Jim will have no problem talking to repeaters that are 150 miles away.
Right.
And where we live here, there's quite a few repeaters. I have over 96 frequencies programmed into my radio. Some of those are simplex, but the majority of them, I'd say at least 85 of those are repeaters.
Right.
And there's not a single one in there that I can't light up.
Right. All right, folks, we're going to charge batteries, grab a bite to eat. I believe Jim is doing barbecue today. You'll just have to take our word for it. It's probably going to be really good. We'll see you in the next segment. Josh, what are we're building the plates now? We're actually manufacturing these, or?
Yeah, we're going to manufacture a couple plates. We need a plate for the rotor to sit on.
Okay.
And we need another plate for the cutlass bearing to sit on.
Okay, that's right.
Which we just ran down to our local auto parts store, brought the pipe with us, told the guy basically what we were doing, that it was not for a car. This was for a radio antenna, and I definitely wanted a tapered bearing, and I needed the ID of that tapered bearing to be specific for the pipe that I'm using.
ID, folks, means interior diameter.
And that's all I really was looking for.
That's it?
That's it.
Yeah.
A tapered bearing with the right ID. Doesn't have to be for any one thing in particular, as long as that ID is correct and it's a tapered bearing.
So he's going to take his trusty Sawzall, and he's got some aluminum stock here, I guess. we only had a vise.
Thanks a lot, Reckless.
Hot Jobs hijinks.
More fun this way, folks.
That's right.
More fun this way.
And besides, you want a new blade.
All right. Maybe we'll go to the vise.
Maybe. I mean, you know, if we only had one.
So Reckless pointed out there's a vise over here on the bench. They're not my favorite things to use. I didn't build it. There's a bunch of stuff on the bench. The Sawzall is a very rattly tool. You might shake everything off the bench.
All right, so Josh is assembling his tools. We're going to utilize a hole saw for mounting the bearing in one of the plates. Using his icrometer.
All right.
We have a hole.
Bearing's going to sit right on top of that, just like that.
Uh-huh.
We're going to drill some holes on 3 sides of this and put some bolts in place so that this bearing's not sliding around.
Doesn't slide around.
You know, this is all about shear. Gravity's doing all the work here. The weight of everything pushing down is basically holding it in place. These bolts I'm going to add are just for shear so it can't slide around on
Okay. And again, we bought this bearing at the at the auto supply store, so we could have used a slightly different type of bearing, sealed bearing, that sort of thing. But sometimes you're at the mercy of what's readily available. So we're going to make sure that it's greased up and for the intended purpose. Again, this is not on an axle or anything. We're not too worried about it. It's just to give it some load bearing.
He's not a millionaire. He doesn't have a ton of money. We're just trying to help him out, get him going. You could literally spend thousands of dollars doing what we're doing here today. If you bought everything that was available through online sources. But see, once I tighten those down, that thing's not going to go anywhere.
Right, it's not.
Hold it right there.
And the pipe goes right there, and it just
pipe goes in,
keeps it down anyway.
Gravity's going to hold it. It's a tapered bearing.
Mm-hmm.
You know, the whole thing holds itself together.
And with that race on it, it just keeps it nice and.
We'll squirt a little grease in there to keep the water out, and away it'll go.
And some of you say, well, you'll have to replace that in a couple of years. Well,
maybe,
yeah, maybe.
Not.
Maybe.
All right, let's get a socket.
Alrighty, so we're putting it into the plate and the bearing.
Oh, yeah. Perfect fit.
Perfect. And
perfect fit.
Let's do the spin test.
Oh, look at that. Oh, man. Well, I don't know if it gets any better than that.
How about that?
Who needs an $80 cutlass bearing?
Alrighty, so that is currently fabricated. Okay. And then we have to affix that to the legs. So
yeah.
Cool.
So what we'll end up doing is that last 2-foot piece of pipe we have,
Right.
it will slide up on this
Oh, will it? Okay.
and into the rotor, which is going to sit right here.
Oh.
And that'll be the connection between the rotor and that. We have this piece here I cut off.
So this slides up underneath. And we'll have to cut that to fit.
Yeah, we'll cut it to length. Now slide right on there. We'll just put a screw in it.
Put a
to
bolt
hold
through
it.
it. Yeah.
The router will be down here.
Rotor. Yeah.
So we'll just need about a 1-foot piece of this. And that'll be what...
And that keeps the torque off the rotor.
Yeah, this keeps the down
Most of the weight. Yeah.
The weight of it off the rotor.
Right.
And also by putting the rotor down here, because this rotor has a brake, and this is a set of beams, and they're wide, so there's going to be a lot of torque generated.
Right.
By putting the rotor down here, with the brake down here, it stops all that torque from being applied at the top of the tower. It's all down here. And in a heavy wind, with a good set of beams, it could actually twist the tower enough where it twisted the tower right down to the ground.
Right.
This eliminates any chance of that happening. There's no way that that's going to happen. Any torque will be absorbed in this pipe. So I like to do it this way. Plus I don't have the extra weight of the rotor up there. Running this pipe right through the center like that also eliminates some of the weight of it all off the tower. This thing is solid. I'm getting ready to climb up there and stack that last set while Reckless makes us the plate that goes down there to hold the rotor. Yes, you're going to make it. You're going to make it.
All righty, we'll be back in the next segment. Folks, Josh is up on the roof, and to get this project done today, we're divide and conquer right now. We've got the rotor now inside the tower, and we've done some adjustments on the tower to make sure that it can spin. At the same time, we want to make sure that this rotor is off. So this is the ASUG 450A. Some of you are probably using this exact same rotor. And what we're going to do is we're going to go ahead and plug her in. And what we need to test is that, again, the rotor is going to be free enough to do what it needs to do. We have to be careful, though. We're not bolted in, so we're just turning things on and making sure that it will want to turn. We also haven't yet attached to the pipe up top. We're going to put a screw through that to mate the two, but right now, just with the weight, it's able to turn. And again, we've already tested for true north. So what we're doing is we're just making sure that the rotor is in a good position. And I'm keeping an eye on the bottom here to make sure that if I bolt it in, it's going to be okay. Right there. All right. So I'm going to be marking those spots, and then we're going to bolt in the rotor. We're also going to go ahead and when I come back, we're going to be also tightening everything down and making sure that everything is going to be mated up properly in the right angles, all the good stuff. So when we come back, we should be right where we want to be. But the rotor is rotoring. We'll be back in the next segment. Yeah, I know.
I'm going to say I'm 7 feet above the top of the tower right now with the tram, wouldn't you?
Yeah. All right, Josh, we've got the tram up there.
Yeah.
Now we've got to find dead center on this horizontal piece.
Yeah, for this cross bracket.
Cross bracket, yeah.
Yeah, I cut this 9 foot, I think is what I cut it.
So we're looking at 3'6".
Well, I mean, I saw where 9 foot was, and then I cut it. I didn't actually put a mark.
Not 3 foot, sorry.
Yeah, I put my, what'd you call it?
Fulcrum?
My eye.
Oh, your micrometer?
I put my micrometer on it.
Yeah, you're at 9'2".
9'2". So 4'6" is half and 9. So 4'7", right?
Yep.
Right there.
No. Sorry. You're 9'1".
Oh, so I need to be 9'6½".
Yes.
4'6½".
Yeah, 4'6½". Sorry.
I'm there.
Then you're all's way. Sorry about that.
It's all right.
4'6½".
I actually think 9 foot's a little big of a spread for these small beams.
Uh-huh.
I wouldn't have gone so big myself. I would have probably stayed closer to 6.
Well, I mean, while it's on the ground, do we want to cut it to 6?
Jim said he wanted it 10.
Oh.
Where I did my own research. Mine are at 10.6. But I'm also 8 element beams that are 12 feet long. These are just 5 elements.
Yeah, he's looking at it from wavelengths away from each other,
Exactly.
which he's fine there. It's just,
There's a certain amount of degradation you get once you exceed 11 feet. That's why I stayed under 11 feet. But I don't know if that is going to work with these smaller beams.
right.
But the only way to find out is we're going to put them together. You need to get the phasing harness on here too and taped into place and draping down.
Let's get that out. All right, folks, we're not going to talk about the screws on the rotor right now, but we are going to talk about this phasing harness. What we're doing is we're running 2 Yagis, or Jim's going to run 2 Yagis here, and you got a pigtail essentially, but it's a Y, and half of this is going to go to one Yagi, half of this is going to go to the other Yagi, and then we will run this down with regular coax. What we were talking about for barrel connectors, you hams know what we're talking about, but we're 259 at the end of the cable and we're 259 here. And obviously that's not gonna work. We need a 239 barrel connector. So I'm gonna go see if I can liberate one of those from his inventory.
If he does not have one, my shiny silver box over there has numerous barrel
Oh, you've got
connectors.
numerous ones.
I carry.
Oh, there you go. They're not expensive typically, but it just seems like when you need one, you're always looking for one.
I don't like giving them away.
Right.
I generally don't, but I do carry them.
That's what we're talking about right there, folks. And again, for the hams, you know what we're talking about. So. But it's basically female to female. So. Also known in the trade as a 239. Why it can't be 259 male, 259 female, I don't know.
It could be. It could be. They just, when they made that in the factory, they were probably thinking you were going to plug this directly into your radio.
Yeah. Yeah.
It doesn't work that way. I also run these co-phase systems with the antennas on my truck, and I tried just hooking it directly into my radio with this co-phasing harness. Most of you hams would know, but other people don't. This is not 50 ohm coax, this phasing harness. This phasing harness is 75 ohm coax, and that's what it takes for the phasing to work. So when you plug that directly into the radio, it doesn't like it. My standing wave was not good. In order to come up with a good, decent standing wave, I had to incorporate a 3-foot piece of coax onto the radio before I could get my standing wave to go right and be acceptable. I'm just gonna get this taped on here so it's nice and clean and orderly.
All right, folks, when we come back in the next segment, hopefully we'll have holes that allow 4 screws to go in, and Josh will have this phasing harness in place. All right, so you can see here that Josh has connected everything. Let's see if we can get that to focus a little better. And this is on both sides, so I'll go ahead and show you both. You know, we have people watching this that aren't familiar with radio and antennas. And even a lot of folks that have been around antennas, they don't use co-phased antennas very often. So Josh has got out what we call an SWR meter, which stands for standing wave ratio. And he is tuning it to a frequency that would be used in what's called the 2 meter band.
Yeah, and so what I'm doing, folks, is I'm just seeing where it flattens out good. What we're looking for is 50 ohms and the best standing wave we can get.
Right. Now, there's two things that will act on this, as Josh was probably about to tell you anyway, but it's so close to the ground that doesn't help at times. But go ahead, Josh.
That's exactly what I was going to say. Is it's showing right now a 3.3 standing wave. That's totally not acceptable.
Right.
It wouldn't be something I'd run my radio on. You would hurt the radio, actually. But I think it's because the radials, the elements themselves are literally touching the ground, and it's right here. I just wanted to make sure that when I did get to 50 ohms, I wasn't so concerned about my standing wave, but at 50 ohms, what my frequency is.
What's your frequency?
I'm at 145.26, which is the bottom.
Yeah.
The bottom of the band.
Yeah.
And when I put mine up and I tuned them up, they did tune up at the bottom of the band perfectly. I never did adjust them. We could trim these driving elements a little bit to bring that up some, but I'm sure once we get it up in the air up there, this standing wave will probably come down to a 1.2 to 1.5 at 50 ohms.
Right.
And I can adjust the frequency. You can see right here, I'm at 145.
Right.
2.2. I can bring that up to 146. The ohms is coming up. It's all getting out of whack. It's not happy right there. We're back to 50 ohms at 153, but we're still at a 3.3 standing wave. We can come back down the other way, get the standing wave down to a 1.5, but the ohms are off at 40. So it would operate at 139, probably transmit pretty good. Not going to transmit great. Not going to hurt the radio with a standing wave of 1.5, but with the ohms at 40, we're not going to be getting the distance we want.
Right.
You really want a good standing wave at 50 ohms. That's key.
As close as possible, if not 50.
Just doing just a spot check here just to see. And that's what I expected.
If he was hitting 147.045, what would it look like?
147.045. Oh.
Yeah, that's close. Come up smidge. But
the standing wave came down a little bit, but the ohms are way up to 80.
Right.
It still wouldn't perform good, but I think that's strictly just down here on the ground.
And again, these radials are literally touching the ground, and that's we just want to make sure that it's in the realm, so to speak.
Yeah, we're definitely within the realm. I didn't want to have a dead short. I would know if it was a dead short, I'd know it. Nowhere would the standing wave have been good.
Right, it would have been infinity at that point.
Right. So just doing a spot check before we get it all the way up there and find out we have a problem.
Righto. All right, next segment. I think we'll probably be off camera a little bit as we try to hoist this up.
Should be able to get up there, get strapped on, and lift that right up to me.
All righty.
Get all my wrenches, I've got the U-bolts, got my tape. If I don't need the wrench, when I send the rope back down, the next thing will be the coax. We'll get it up here, get it all, and I'll tape it up. When I do raise this pipe, I'll need you to steer this one, or I can set this one down inside this one. I'm already at the top.
Nice.
Didn't take very long.
Not a 150-foot tower, is it?
No. It actually surprised me when I felt it. I was like, wow. It takes me like 20 minutes to climb the 995.
Oh, wow, really?
Yeah, it's 150.
Is it 150?
Yeah.
So folks, what he's doing now is he's getting harnessed in. When you're climbing towers, you want to use the right harness, and you want to make sure that you know how to use it. And Josh climbs towers for the clubs in the area, plus the rescue squad and things like that. So he's well versed with the climbing gear that he needs for this type of work. But this is not for somebody who's obviously going to have a problem with heights. And if you're brand new, you need somebody to train you on harness setup and how to utilize it correctly on the tower. So.
And you should also have a safety plan that you at least thought about. If something was to happen up here, how would you get yourself down?
Right. It's on you. Almost, anyway.
Okay.
Got it?
Yep.
Okay.
You know what?
Sir?
My microphone is up here stuck to the mast.
Is it really?
So somewhere I must have lost my,
Oh, the little backing?
well, I mean, unless it's in my shirt.
Could be.
Okay.
But you've got the mic itself, right?
I've got the mic itself. I just looked at the tower. I'm like, huh.
You could put it on the tower. But you're about to hoist it, I guess. Or not on the tower itself, but on the mast?
Yeah, it's actually on my harness right at the moment.
Oh, okay. Well, that'll work. Feeling good about it?
Oh, yeah.
Okay. Once Josh gets where he's comfortable with the bracket, we're going to lift that up about 3 feet. The mast that it's on, and it'll go on the one that I'm holding here in the middle.
We're going to have to get our beam swung up, Brian, before we do that. 'Cause once I raise this up, I'm not going to be able to reach it.
True, that's true.
Oh, I'm just about ready to go there. I've just about got this tight. It's definitely not going anywhere.
I mean, you're good, but you're not 10 feet tall. But we need one of those monkeys that escaped.
One of the escaped monkeys?
Yeah. I bet if we had one of those, this video would go viral.
I wouldn't need to be up here.
Do you see what I did there with the monkey?
A monkey could do it.
The video would go viral.
It would go viral. Ha! That's good, Brian.
I mean, come on now. I don't care who you are.
That is good stuff right there, man.
Because they did escape a viral lab, didn't they?
It escaped from a viral lab. I think it's what we need, dude.
Absolutely.
We need the monkey.
We need the monkey.
I think I'm actually pointed a little high right this second. From where I'm standing, it looks like I'm up a little bit more than 2 degrees.
Folks, I'm going to zoom you in just a little bit. So. Oh, you've already got it turned, don't you?
Yeah, I did. I didn't even need the wrench, man. It's a lot lighter than it looked. I was a little...
Those look good to me from down here.
It's up just about a degree above level, isn't it?
Yeah.
Definitely
No,
up above level, but not too much.
No. I think they look good. Just trying to look at it from more than one angle. Well, from this angle, they look pointed down.
Oh, they are pointed down now.
Now we're hitting satellites.
About right there, huh? That's still a little high.
Well, I'm just wondering if it'll settle down a little bit.
Yeah, I'm still tightening up here, and that seemed awfully easy.
They're coming down a little bit as you tighten, so I think once you get tight, it'll be about where it needs to be, but it's in a good spot right now.
Oh yeah, I like that.
Like that? So folks, what we've come up with is we're gonna have to create a physical brake so that the mast doesn't rotate, the horizontal one. Swap this out with the other one and the 2 screws.
Yeah, you can just screw the screws into the very tail end of the rope.
Oh, okay. I got it.
That took care of that.
It looks good. It's slightly above horizontal. All right.
Oh, that really made a difference, man.
It's going nowhere.
All right. The rest of the way.
Sounds like a plan.
Yeah.
Yeah. Feel good about it?
Yeah.
All right.
I will need still one more self-tapping screw to screw into that joint down there.
Okay.
All right, coming up with the coax.
Just about perfect. How you feel?
Huh?
How you feel about it?
I'm okay with it, bro.
Good deal.
For what we're working with, I think we did pretty damn good. Finding anything? Well, just send me up that other drill with a couple screws and I'll drill a hole and shoot it in.
Just like the other ones? All right.
Yep.
We can do that.
Send me up 2 screws and that other drill. And we'll make her happen.
We'll make her happen. All right. I can do that.
And then I'm gonna come down, Brian, and we're gonna go inside and hook to the existing coax because that's what the beams are on.
Right.
We already know the tram is good.
Got it?
Yep.
Yeah, we got about 15 minutes. Folks, I've had to hook up to some power because my phone is really low, so the audio is going to be different, but Josh is putting a screw in the 2 mast pipes where they come together, and that way it won't just spin one pipe within the other. And we've got to do the same thing down at the bottom as well. All right, folks, so I'm going to come over here to the tower to kind of wrap up the look of it anyway. And you can see the rotor there in the center. That's been anchored to the plate. We have to do a little bit more work on that plate, anchoring it to the tower itself. But as we keep going up, you can see the TIE fighter arrangement up there, plus the tram antenna at the very top. What is that, 17 feet?
The tram?
Yeah.
Yeah, it's a 17-foot tall, 3 5/8 wavelength stacked.
Yeah, 3 5/8 wavelength stack. So, I mean, he's got a lot of horsepower on this setup, and that's what he wants. And then sometimes that's what hands are looking for, is just that extra little oomph to get out where they want to go. So, in the next segment, we will sign off. Alrighty, to finish out the Odd Jobs Hijinks project here, Josh, how'd it go?
Pretty typical day here at Odd Jobs Hijinks. Pretty typical day. We had some modifications we had to make. You know, we came into this kind of knowing what we were getting into.
Right.
We had kind of looked at the stuff. He had ordered some stuff offline. You know, I'd kind of looked at it, but, you know, we had to make some modifications and shoot from the hip. And we still accomplished the mission. Tower's up, 2 antennas, beams, rotor, everything's installed. We're going to go inside, check our standing wave, and get a radio check, and I think we're golden.
I think we are too, and I only had to use a stepper bit once.
Yeah, that's great, man. That's great. You know, that's part of it. That's part of all this. You know, all this is sometimes it's just like that. So we're going to shake our gear off and do what we got to do. Subscribe, like, even if you didn't like it anyways. Odd Jobs Hijinks.
Take care, everybody.